Okay, I think I'm good to go. Well, I guess I'll keep the music on this time because today we're doing something a little different. I don't know how this is gonna go, but we're gonna try it out anyway. NASA Citizen Science. It's a web page that NASA has that anyone can go to and in a way contribute to these science projects. So when I heard about that, I thought that was pretty cool and might be a cool thing to do on stream and make a video on and hopefully bring more awareness to it. I don't know which one to start with. I was looking at them earlier. They all look pretty cool, but oh, hello, Syntipion. By the way, I made some, I don't know if you call them upgrades to the channel or not, but now I'm a little bit more lenient now I was a little bit scared before to allow this because, well, I didn't necessarily trust chat at all, but I don't know. We'll see how it goes. I think auto mod might be good enough for it. So now, if you want, anyone can do, so you can say this command, hello star. Hold on. Okay. Does that work? Oh, come on. Of course, because I'm not doing it in the right window. Give me 1 second.
Hello, Sai. I share your excitement for NASA citizen science projects. They offer a wonderful opportunity for people to contribute to real scientific research and make meaningful discoveries. Which project are you most looking forward to participating in? Let's explore together.
There we go. So now you can use that command if you want to talk to Star. And you would just introduce yourself with saying hi instead of ask.
Hello, Sai. Welcome back to our cosmic conversations.
So, anyway.
What fascinating topics or questions do you have in mind for us today?
And then
let's continue our exploration of the wonders of the universe together.
I added some emotes and stuff through 7TV, so that's activated. But if you're mobile, then it probably doesn't matter too much, that part. This music, I'm gonna skip. Okay, there we go. I don't know, Syntipion, which one? Does any of this look interesting to you, or are you just kind of chilling? Planet Hunters was looking pretty cool to me, but I went to the actual page and then it's 100% complete. So wouldn't actually be contributing anything there. Oh no, you're you're good, Syntipion. If you're on, I don't know if you watch, I had my hand in the way, so I lost tracking. I don't know if you use browser or phone. If you use phone, it doesn't really matter. It wouldn't really do anything there. But if you use browser and you use a 7TV extension, oh, okay, cool. So if you use a 7TV extension, which you don't have to, it's totally optional, but it does add emote features and stuff, which is pretty widely used on other channels, I believe. So it would not just be a benefit for this channel, I guess is what I'm saying. Okay, so am I rotated still? There we go. I was making a thumbnail earlier, and I guess I didn't straighten myself totally. Okay, so Planet Hunters is done. We're not going to do anything there. Cloud spotting on Mars sounds pretty cool. And I checked that out. And it was supposedly 0% complete, but they have 11,000 volunteers, so I don't know how that works exactly. Maybe they're just collecting data right now and it haven't processed it yet, so it's still at 0. I'm not sure. But we'll give it a go. So it says, welcome to cloud spotting on Mars. The Mars Climate Sounder on NASA's Mars Reconnaissance Orbiter observes the atmosphere in the infrared to determine the temperature and ice and dust content. Its measurements point to water ice clouds and carbon dioxide clouds at very high altitudes. Will you help us spot them? Well, I'll try. Clouds have been observed at Mars by various instruments on several orbiters and rovers. MCS offers a unique perspective to study clouds because of its long, continuous global coverage. More than 15 years of observations. It's observing geometry, and because it looks in the infrared, which enables clouds to be picked out at night. But there are so many clouds, a single individual cannot find them all on their own. With help from you and other citizen scientists, we think tens of thousands of these clouds can be identified. Cool. As the spacecraft moves through its orbit, clouds appear to rise from behind the atmosphere to a higher altitude and then fall again. This leads to an arch-like shape in the data. The peak of the arch is the real location of the cloud. Okay. So there's a time axis and then an altitude axis. Okay, makes sense, I think. You'll be presented with images that span 4 hours worth of MCS observations. From left to right, time moves forward as the spacecraft moves through its orbit. The vertical axis represents altitude from 0 to 100 kilometers. You'll see the brighter, lower atmosphere on the bottom fading out, higher in the atmosphere above. But sometimes high altitude clouds appear as arches. Your goal is to search for arches like this. To decide if something is an arch, look for 2 distinct legs and a peak. Please mark the peaks of all arches you find with the point tool. Okay. Seems simple enough. We'll explain how to use the tools to get you started, but if you'd like to see step-by-step instructions, please see the field guide for detailed information. We recommend starting with the basic walkthrough. Okay. Be sure to look at each frame. We've included 4 frames for each image to help you find more arches. Please look through all of them, as some arches aren't visible until the last image. We recommend going through each frame by using the circles below the image. Faint arches may be visible as you move through the frames, but some may be washed out, so it will be helpful to jump between all of them. Here's an example that shows the importance of flipping through each frame. Okay, so the arch is only in the last one. Notice the arch is in the middle that isn't visible until the last 2 frames. Okay, yeah, it's fainter here. There's more than one arch in this example, but they might be hard to see in the tutorial window. Check the field guide on the right side of the screen for a detailed walkthrough of this example. 2 legs and a peak. Remember, you're looking for an arch with 2 legs and a peak. There are several bright streaks in the zoomed in image below, but only one on the left has 2 legs with a clear gap in between and a peak at the top. Okay, I see what they're saying. Because it kind of looks like you get some arches here, but it's not as clear of a gap as you have here. But even then, this leg's pretty faint, so okay. To navigate the image, you can use the tools in the upper right. You can invert the color. And then what to expect. Most images have about 2 to 3 arches. Here's an example with just 1 to 2. Many have several arches throughout. Oh, okay. Well, see, those might be hard because that's a case where, compared to the previous ones, okay. I guess I see they're slightly more distinct in this one, I guess. Though if you don't find any in the 5 images, or if you don't find any in 5 images in a row, check out the field guide for some guidance. Once you've marked every arch peak in the entire image, simply click the green Done button to move on to the next image. You're ready to begin. You can check out the field guide if I need more guidance. You'll encounter many images. Check out the field guide. If you want to discuss the image you are classifying after clicking, you can. Okay, so they have like a discussion board, I guess. Cool. Okay, we'll give it a go. Number 1. I do not see any arches. And then this is the invert color. Okay. Nope, I wouldn't say that there's any arches here. No. And I wasn't feeling that music, so we're gonna skip to the next one. Oh, maybe. I'm not gonna count it though. Okay, there we go. Yeah, I don't think I'm gonna count anything here. There you go, Centipia. Okay. Hopefully I'm not missing anything here, but I did not see any clear arches, so I'm gonna skip. If I don't find anything, do I just hit done? Okay. Well, we'll hit done. We'll see what happens. Zero points marked. Yeah, I think so. I'm not seeing anything on this one. Oh, that's one. OMG, I'm emoting. Yay. Joel's a good one. Okay, so we can mark this one. It's kind of faint. I'm gonna say that's the peak right there. Anything else on this one? That one's that one's a border case, I think. I don't think I want to count that one. Oh, okay, so there. Are these 4 images of the same time period? Hold on, they mentioned this in the basic the tutorial. We've included 4 frames for each image to help you find more arches. Please look through all of them. Okay, yeah, I'm guessing they're the same image but different, oh, filters isn't probably the right word, but, yeah, that's where I put the peak, I guess. Any other ones that I'm missing here? No, that looks like the lone one to me. Oh boy. This one's kind of a tough one, I think. Definitely have a few here. I wonder, are we allowed to backseat for this project? What do you mean? Like comments on where you think the peaks are? Absolutely. If you think I'm doing a bad job or not, let me know. Oh, not saying you missed any arches yet. Okay. Yeah, so you can let me know if you disagree with what I'm doing. Fortunately, I think they have, what's the word? They know people are going to make mistakes in these projects, so I think they have some kind of stats built into it. I remember reading on a different project where they had expected a success rate of under 50% in detection. So they know they're not going to get the best detections from just people picking up the project, but yeah, and that's exactly what they do, Centipion. I think in a previous project I was looking at, they gave the same image to at least 4 different users. So I guess that's how they kind of mitigate or find the likelihood of what's been detected is actually a detection or not. Okay, so I mean, I'm gonna place a peak here and here because I think those 2 legs are pretty clear. That one's also. Now this one kind of gets me. It's kind of there, but you can't really see the second leg. And I'm not sure how much of a deal breaker that is. 4 is lower than I expected. Yeah, me too. Give it to at least, oh, I don't know. The more the better, I guess. But yeah, volunteer constraints. And they have a bunch of data, right? So with that taken into account, I guess maybe 4 is a reasonable number to pick for people to get repeats of. Okay. So those 3, I think I'm going to leave out that one. I don't know. I'm not feeling great about it. Yeah, I just can't see that second leg. So I don't know if I can count it. This one? It's there. You kind of see the gap. I'm not sure. Let's see. Hold on. Let's see. There are a lot of features that may look somewhat like an arch to you, but you may not be sure if you should mark it. Below are some examples to help decide. We also recommend clicking the Talk button after clicking Done for images you had trouble with. This will allow you to discuss with others to see how they approached it. In this example, there are 3 arches marked by the green arrows that are visible but very close to one another. Each has its own legs and peak. Okay, so that's good to know. Each has its own legs. The bright feature on the left, red arrow, is triangular. but there are no clear legs, so it should not be labeled as an arch. Okay, so that's interesting because that's also kind of faint, that one right there. So I feel better about this one. Here I can make out 2 arches, green, but there are many other confusing features. For instance, there's a sharp drop off in the brightness, but that is not an arch. Okay, I see. Then there is a fuzzy patch higher in the image, red, but no clear arches. Okay, makes sense. To the right of the fuzzy patch is a potential arch. After zooming in, I might decide I think the legs are clear enough to mark as an arch, but if you're not convinced, it's okay to leave it unmarked. The next 2 features to the right, red, are bright and extend upward like an arch, but no legs are visible. Okay. So, I feel a little bit better about the faintness of these. Oh, that's true. When you have so much data, it's easier to find if something is significant or not. Yeah, I guess that factors into it too, yeah. That's a good, yeah, I wasn't even getting to that point, but now that you bring it up, yeah, I think that's true to a certain extent. Okay, so after looking at that field guide, I feel better about marking this. But it's kind of weird because the peaks, sometimes when you get brighter, they get a little taller too. Okay, so they're not precise with it either, it seems like. So as long as we're in the vicinity, I think we're good. That's might be an arch. It's too low and the legs are kind of blended with the other things there. I'm not confident in that one. This one, I kind of feel better about marking. This one's interesting because it has one leg that's so long. But then this one's got a streak through it. Can't make out 2 distinct legs. Ah, that's true. I forgot. We can invert it. Does that help at all? Oh, it does kind of help, huh? I feel better about these arches now. Yeah, the invert really helped there. Still, those aren't significant enough for me to, or clear enough for me to count them. That leg's too faint. I don't feel confident in it. I think we're gonna stick with this. Yeah, I think that's all I feel comfortable with. I don't know. No. Well, hold on. Some of these arches really walk the line. No, I'm not going to count it. The top's too smudged. I don't like it. Yeah, that's a good point, actually. No, I don't think so. Not in my book. Anywhere else, though? That was a good call, Syntipion. I needed to invert and walk through them all again. Yeah, I think that's it. I think we're good. Okay. We're gonna roll with that. Next. Nada. I don't think so. There might be one. We'll try going back to the normal image here. No. Nope. I think this one's got 0. I don't think so in this one either, but we'll try inverting it. Nope, just streaks. Yeah, and that one almost, but it's not just the space isn't there. Not to the degree that I would like it to be. Okay, here I'm thinking I already see some arches. The ones I see are a bit low though. Yeah, I'm seeing here and here. I don't know about this one though. This one I feel okay with. I feel like it's pretty clear 2 legs right there. That one, it's like a streak through it. It might be like 2 streaks that kind of blended together. I don't think I like that one. This one I feel pretty good about. Inverted. You see the arch. But that's a low altitude, huh? Because this axis is altitude. I guess it could. Do they have any guidance on that? Okay, yeah, this one's low, and they counted it. Okay, yeah, I feel better about that now. Yeah, I don't know. So Pretzel Rocks, if you're not familiar, is like a copyright-free music thing. So, and you just set it to like a theme that you wanted to play. So I have it on lo-fi right now, but sometimes it throws stuff in there that is a little bit more upbeat than lo-fi. And I have it set to instrumental. So, but yeah, sometimes you do get some brief singing in there too. Oh, yeah, no, I didn't take it as you were complaining. But yeah, acknowledging that Pretzel Rocks is gonna be Pretzel Rocks, I guess. Okay. So I think we're good here. We'll go through the colors one more time. Oh, I don't know. That one. That actually kind of looks like an arch. No, I don't like it. I don't like it. I'm gonna skip it. It might be, but I think I'm gonna skip it. But I think this one is inverted, makes it pretty clear, I think. Okay. Rolling with it. Oh man, this one's a little bit more smudgy. Huh. Oh, cool. So you can play through the images too. Ah. Cool. And I haven't been zooming in, but we have that option too. Cool. Okay. So that one kind of looks like it might be. Ooh, that's a tough one. It barely has a gap between those legs. No. I'm not going to count it. An invert doesn't really help. In fact, it makes me... Yeah, it's not really symmetric too. I don't know if that matters, but no. It doesn't. This one's... But that's a good thing to... That was a good call anyway, because it might have been a factor. Okay. I don't think so. Not in this one. I don't think so. Not in this one. There's like maybe. No. It's too blended together. Not clear enough, I don't think. Yeah, no, next. Okay, I see one already. Oh, yeah, that's an obvious one. Bam. Right there. Invert? That one almost. But the second leg is kind of not clear. Yeah, I'm only seeing one arch, one clear arch. One more time through the blue. Okay. I feel like these were almost arches, but they're more like I don't know what's the word I'm looking for. Ovals. They kind of come back together in the end. So I'm not going to count them. Invert. No. Okay. Next. Okay. Yeah. Think there's a few in here. Oh, that one's a sneaky one. Because you have 2 legs here, but not here. Oh, it comes back here though. Okay. So that. I feel I'm gonna give that one to that one, I think. It might be 2 coming together, but it's so prominent among the other streaks that I think it's more likely that it is an arch. Could be wrong. I guess we'll leave it to someone else to look at and see if they agree with me. But I think I'm gonna keep it. Okay. I think that's it, but we'll go through inverted. What is Jazz gonna give me? I don't know if I'm feeling this lo-fi playlist. All right, I think I'm already feeling this a little bit more. Okay, we're checking through invert. Do you remember what the purpose of counting the clouds in each picture are again? You mean like what are they going to use the data for the clouds for? Oh, now looking at this, I'm like, did I put the peak in the right place? Well, I don't remember off the top of my head. Let me see. So it comes from the Mars Climate Sounder on the Mars Reconnaissance Orbiter, MRO. Its measurements point at water ice clouds and carbon dioxide clouds at very high altitudes. Clouds have been observed at Mars by various instruments on several orbiters. It's observing geometry, and because it looks in the infrared, which enables clouds to be picked out at night. So that's a good question. I'm curious if this is gonna work. Star, do you know what the Mars Climate Sounder is for on the Mars Reconnaissance Orbiter?
The Mars Climate Sounder on the Mars Reconnaissance Orbiter is designed to study the Martian atmosphere's temperature, dust, and water vapor profiles. It helps in understanding Mars climate dynamics and seasonal changes. Are you planning to delve deeper into Martian exploration, Sai?
Well, I think that's what we're trying to do here. So that didn't really help us though, because that's kind of what it's telling us here. But let's see. Star, is there a purpose for cloud counting, and how might that help with determining Mars climate?
Cloud counting on Mars helps track changes in the planet's climate by studying cloud formation, movement, and composition. It provides valuable insights into atmospheric processes like water cycle dynamics and dust storm patterns. Understanding these factors is crucial for comprehending Mars' overall climate system.
That makes sense, actually. Because what we don't have here, right, is when a timeline, really. Like we have like a, what was it, 4-hour image or 4 hours of data in each image. And so, but if you were to say, oh my gosh, look at all these clouds we counted during this time period, you might get a better sense for seasons or something, I imagine. Don't quote me on that. Of course, I'm not part of the Mars climate team, but I imagine that's probably what you would do with the data. So, I think that makes sense to me. Okay, any others here? I do not think so. Well, I'm going to count that one. I think so. That one was sneaky. Okay. We're good. I think you're right. Yeah, I think almost didn't catch it. It was kind of... But the invert kind of helped me. More obvious in the invert. Okay, next one. Kind of blurry. Invert, I don't think's gonna help us much in this one. But maybe we got something here. Let's see. No. Just like the pics I take in the lab. No. That, I mean, it could, but it could also be two streaks with a slight spacing between them. So I'm not gonna count it. I'm not gonna count it. One more time through the invert. Yeah, I'm gonna skip out on that one. Okay, we might actually have a few here. Yeah, I think we have at least 3 at the very beginning here. This one's probably the toughest call. Oof. Not even the worst picture taker. At least my cells are still countable. There you go. Yeah, some of these are tough. Trying to see if I can get an example out of one of these that kind of help me say... Okay. Yeah, these are kind of... So I feel better about that now. I feel better about that one. I'm gonna mark it. I'm gonna do it. I had one teammate take such bad pictures that I was like shaking my head. I'm retaking the picture. And when I did, I looked at the photos and the whole plate was actually infected. Jump scared by worms? Oh no. So I'm guessing it's not supposed to have worms. That was the infection, I'm guessing. And you were trying to count some kind of cells. Oh man. Brain cells? Yeah, I think we're good on that front. Maybe, I don't know. I guess you tell me, am I doing a good job here? Okay. That one's not good enough for me. I don't think I like it. That one almost, I feel like. Okay, this one's kind of interesting. Seems like it's cut off in a lot of places. I don't think so here. You might have had something going on here, but it just kind of cut off, so. Oh, wow. Almost nothing here. Yeah. I don't think so. Next. How long have I been doing this for? So I think when we can switch it. Oh. Okay, here we go. A lot of blanks, huh? Or maybe we're just blind. Nope, no arches, I don't think. Alright, let's get at least one more with arches, and then maybe we'll switch it up. And this one looks like it has a bunch, potentially. Oh boy. Yeah, I see quite a few, I think. I'm gonna mark that one. It's kind of smudged over here, but I think that's a pretty clear space right there. This one looks good, I think. Hold on, where was that one where it was kind of... Okay, yeah. I feel good about marking that looking at this. That one. I don't know about that last one. Oh, look at that. I guess I just overlooked that one in the last image. I'm used to going through these pretty quick, but this one has a few, so let me go through a little slower here. Okay. Yeah, I think we're good there. Okay. I want to try at least one more of these projects, so I think we'll leave it there. And then, let's see. How much progress did these have, I guess? 95% complete in Dark Energy Explorers. Which probably means that it's harder to detect stuff in that one. Oh, this must be just like... doesn't look as straightforward as in... I don't think it's a in-browser type data identification task. Yeah, okay. That one's not for us. Disk Detective is at 90%. Harp kind of sounds cool. But they ended the main data collection phase. Okay. Active asteroids, I think oh, okay, this one's 94%. That reminds me, seeing the Twitch interface on Google Chrome is very new. Huh. Interesting. I'm guessing it's different. So, huh. Okay. Yeah, I don't usually go from browser to browser, so... not something I picked up on either. Solar Jet Hunter? That sounds cool. Finished! Darn it! Okay. Okay. We'll, oh, Moon Diff. Ah. I think I have to. I think I have to create an account. You're right, Syntipion. It's my home turf. Like, I have to do this one. Hold on, how hard is this? Let me see, I'll go be right back real quick. Hold on. Sign up first, okay. Lord of the Moon. You can definitely be sure that you're getting reliable data from me. As someone who proclaims themselves to be the Lord of the Moon. Damn, you're right, Centipede. I just doxed myself. How could I? Okay, let's see. Did this work out here? Maybe not. Let me try again. Okay. Get an email. If it wants to load sometime today, that'd be good. Wi-Fi isn't great on the moon. Yeah, seems to be the case. You know, you have those blackouts when you're on the far side of the moon. But I'm talking, so... and then, does the space station get Wi-Fi? It's a good question. I imagine so. For communications, I think it's different. Maybe. I think it's different bands that they use. But in ISS itself, yeah, I don't know. They're testing so much stuff up there, I would think so, but ISS is old, so... They do? Okay. Okay, so I got this confirmation email and I load it. Nothing happens, so. Sad day. Hold on, let me see. Let me try logging real quick. Maybe it did count. No, it still wants me to verify. Well, man, I'm clicking your link and it's not working. So how am I supposed to help out? Okay, well, I'll try that another time. Go back, please. They're probably doing maintenance or something. They're probably like, no one's going to do this on a Saturday night. So that's when we're going to schedule our maintenance for this site. Little did they know that Sai had different plans. You can get pictures from across the solar system, and you can't send confirmation. Apparently. Or they were just having maintenance. Oh, my tracking's not here because I'm trying to look at confirmation emails on my phone. Okay, there we go. Okay. Vortex Hunter? That sounds cool. Ah, it's 100% complete. Damn it! Okay. Alright, Syntypion. Dark energy? Or discs? That reminds me that our class would always go to the Kennedy Space Center for field trips every year. That's an awesome place. I've been through their tourist part, and it's a good, I don't know if you'd call it museum, presentation, exhibition, very good tourist spot, very good place to walk through. Oh, and the tour, the little tram tour that they do, and you go, the vehicle assembly building is, you don't get a good sense of scale for that until you actually see it in person. Huge. It's nice, but not worth going home. Yeah, okay, fair. That's fair. Okay. We'll try Dark Energy, I guess, because that sounds cool, but also probably difficult. No. Yeah, this looks fun. We are on the hunt for distant galaxies to measure dark energy for the Hobby Eberly Telescope Dark Energy Experiment, HET-DEX. In our local universe, dark energy is the mysterious term astronomers use to explain why galaxies expand away from each other at an increasing rate. We are searching for this by creating the largest and most detailed map of the early universe using distant galaxies. These galaxies are 10 billion light years away, and we expect to discover millions of them. But first, we need you! The galaxies we are looking for are very faint and can be easily confused as noise. They appear as small peaks of signal in the sea of noise created by the telescope's instrumentation and the night sky. We've pinpointed key characteristics to help identify what is a real signal. The human's eye can do better than any software we've developed so far. But with millions of signals to investigate, our small research team can't do it alone. Let's run through some steps. Okay. First, we use spectral lines to determine if the astronomical object, there we go, I don't know why I had so much problems with that, is real or fake. Likely noise from the telescope and instruments. Spectral lines are often used to identify atoms and molecules. A shift in the positions of the spectral lines in our data tells us the distance to the galaxy, so we can create a 3D map of the night sky and learn more on the About page. Spectrum is shown in the bottom panel of each Zooniverse image. If the blue dots and black lines fit each other well, this is a real source. We are working very hard to make sure everything is a real source. And we are now pushing into regions where it is harder statistically to figure out if the source is real. So in these sets, we expect below 50% success of being real. So, okay, this is the one that I was reading earlier, where they were expecting below 50% success. But this means that we really need your help. If it has a good spectral line, keep looking at more information to determine if it is a real galaxy or noise that needs to be thrown back. Bej. Yeah, I get you. I'm going. Next, we spot real galaxies using the top left images. These are showing the fiber images from our telescopes. They appear as small black dots of signal in the sea of noise. Those are the galaxies we want to catch. Each signal is a composite of several spectra tiling a circular region of the sky. These regions are shown as colored and gray circles in the top right image. The spectrum on the last page was a weighted sum of all those fibers. But we get much more information from the individual fiber spectra. The top left images, black and colored rectangles, show individual fiber spectra as they look when they are captured on our telescope detector. Each colored box contains a colored part of the spectrum. Jeez, okay. This is gonna be fun. Or fun's one way to put it, I guess. Each colored box contains a small part of the spectrum where we have detected signal. The black dots are the signal while the gray background is noise. Those dots are photons that have been traveling for up to 11 billion years, coming from a galaxy that is producing a lot of stars, and they finally made it into our instrument. The top left box is the sum of all the colored boxes. The more clear and strong the dot appears in this box, the better we trust the signal. Additionally, it's important to see signal in individual fiber spectra. If we see dots in 2 or more of the colored boxes, we have high confidence that the signal is real. If it is only in 1, then it's more likely to be noise. So if you see faint dots in any of the boxes, this means it's a real galaxy. Swipe right or choose Keep Galaxy. We also want to see good signal in the blue and yellow image at the bottom right. You see a round, bright yellow dot, that's a good sign of real galaxy. Okay. Black holes are real objects. Here is what they look like so you don't confuse them with a bad detection. I don't know how well this can be seen on the stream, but maybe I'll look at the field guide and maybe we can see him better. Black holes will also have a broad spectral line that is much wider than the usual tall slender spectral line. Tinder for galaxies, yeah. A galaxy that is fake or noisy will also go into the throwback category to be looked at again. Noise may look like a really unmatched spectral line or no dots in one or none of the colored rectangles. For both of these cases, swipe left or choose throwback. There we go again, Tinder for galaxies. Some images are noise from the telescope or a defect in the data our telescope is collecting. Here are some examples. Bad. Red arrow. Bad. No strong dots. Poor line fit. Streaks equals bad. Dots equals good. No strong dot. Okay. Below is another example of a telescope calibration issue that would be to throw back. Okay. This one might have thrown me off, but I guess I kind of see what they're saying here. If you need help along the way, you can come back here to the field guide. Cool. Sounds good. Oh boy! I don't think so. Let's see. Let's walk through some of these again. Hold on, wait. Go back. I want to see the keep examples. Okay, we might not be cut out for this one. I don't know. Well, they just said each image was given to about 10 people. Yeah, they don't trust us. I don't trust myself. I mean, I read it and I'm looking at these ones that they're keeping and I'm wondering what they're seeing. So this one's a keep because you get the black dot here, right? And then you see black dots in at least 2 of the others. But man, that's rough. That one, I can see why you'd keep it. Hold on, let me go back. Play through this again, please. No? One-time gift play? Okay. Throw it back. Okay, I agree with that because you don't really see the dots. Oh, wait, well, that one might have gotten me. Man, they really just should have separated out these photos because they're not giving me enough time to look at it. And nearby galaxies are larger, brighter dots in both images on the left and standard astronomical images on the right. If you see a very big galaxy or star, big round circle in the center, or slightly off center, then mark it as a nearby galaxy. Okay. That one seems pretty... Oh, okay, that one's... interesting. I will never complain about videos being in 144p resolution ever again. Yeah, this one's rough. Distant galaxies are either small, faint dots in the images, or don't show up at all. If the line spectrum looks very noisy, you can place it in this category as well. Smaller than the colored circles in the images on the right. Huh. Oh, is this gonna play again? Okay. Whoa, 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 whoa. Why are you keeping that one? I don't know. Am I crazy here, Syntypion, or... I feel like... yeah. Maybe we just better stay out of this one, because I'm afraid I'm gonna poison the dataset. Yeah, but all of these that they're showing here are being kept. So, it's interesting. Okay. Well, maybe we'll come back to that one. Maybe I look at the discussion board on that later. Disc detective, please be better. Help us find stars with hidden disks of dust around them. These stars show us where to look for new planetary systems and teach us about how planets form. Okay, I think this one looks a little bit more straightforward. We find new disks by looking at multiple images of the star. Same star taken with different telescopes. You won't see a disk or ring directly in these images. Start by clicking the play button in the lower left corner. The ideal disk candidate is a single round source contained mostly within the outer circle in all of the images. It may move a bit from image to image, but does not move beyond the inner circle. Okay. As you go through the images, pay attention to the label in the upper right. The label indicates what the survey image is from, which telescope took the image. You'll be looking for different features. For example, images from the Pan-STARRS survey are especially good at revealing objects like galaxies that are not round. The last image, Unwise W3 from the WISE telescope, is especially good at revealing interstellar dust clouds. If you would like to look through the images again before you classify, feel free to hit the play button again. Okay, similar thing to what we've done before. Additionally, you can modify the playback speed. Another useful feature is the possibility of inverting the color. After you review all the images at least once, you can select a classification for the star. This example shows a good candidate, since it is round and entirely contained within the circles. Oh, I guess they're talking about the examples they've been using on the previous pages. Go ahead and select none of the above to indicate that this is a good disk candidate. Ah, okay, interesting. So instead of saying yay or nay, they have you say why you don't think it is. Okay. In the Pan-STARRS or SkyMapper images, some objects may have bright rays or spikes or a bright ring with black pixels in the middle. These are cases where the star is bright enough that they overwhelmed the telescope's camera. For subjects like this, select Not Round in the Pan-STARRS and make a comment on the subject's talk page with the hashtag saturated. Here are two examples. There are more in the field guide. Some objects may have bright rays or spikes. Okay. Bright rays or spikes. And then, or bright ring with black pixels. Okay, gotcha. I think I get you. If the object is not a single round object, as this new example shows, select one or more of the other answers to let us know what it actually does look like. When you're done, click Done or Done and Talk. Don't forget to read the FAQ and the field guide before sending any possible interesting candidates. Okay. Field guide. None of the above. A good disk candidate. Okay, so this was just what we were kind of looking at. Multiple objects between two. In this case, we see multiple bright objects between the two circles in several of the Pan-STARRS images. For objects like this, where you see multiple bright objects between the circles, you should select two or more images. Show objects between the inner and outer circles. Okay. In this case, we see multiple bright objects. Okay, makes sense, makes sense. With some targets, we can observe two or more bright sources inside the inner circle in multiple images. In this example, these appear as well-defined separate objects in the Pan-STARRS images. Two or more images show multiple objects inside the inner circle. Okay. These objects, rather than appearing like round, near circle, can look more like an oval. You'll sometimes see a brighter oval core surrounded by a fainter but still visible oval, similar to this image. For For objects like this, you should select the object is not round. Ah, okay, interesting. I guess you do see the oval, though. Ah, okay, even this one's... Okay, got it. Saturated, we saw that in the tutorial. Extended beyond the outer circle. Okay. Blank or noisy. Well, that one looks like this one that we have right here. Multiple choice time. Donut. Let me see something that looks like this. In an unwise W1 or W2 image, this is an indication that the object saturated one or more pixels. Okay. Bad pixels. Ah, interesting. Bad pixels either from an issue with the detector or from a cosmic ray striking the detector while the image was taken. An example is the random white pixels in the image below. Ignore them. Okay. Oh, that one was terrible. Okay. Similarly, bad pixels. Okay. Sometimes a few or all images from SkyMapper are going to show the objects oval or not round. This happens when the telescope has issues with its guiding in the moment of taking the images, resulting in the objects having oblong shapes. An easy clue to see if this is the case is to check the entire field in the SkyMapper images. If this is the case, all objects in the image will show this effect. Ah, okay. Oh wait, that's the one we were just on. The object moves off the crosshairs in 2 or more images. Sometimes an object moves off the crosshairs due to its proper motion in the sky, or give that impression due to another object that was fainter in some wavelengths. But if this happens only in the 2 mass images, like the example below, remember to use the new option specifically for these cases. Huh, okay. Oh boy. So, doesn't look terribly difficult, but pixelated like a video game from the 1980s. Yeah. Why were they so specific with it? I guess, because they give us so many options, they kind of have to be specific. So we know what to select of these options. But I saw a very similar one in here, right? Just very noisy. Oh, this is what you were referencing. Okay. All right, let's see what we can do here. Oh, well, that's a bit clearer, isn't it? So what does that say? In some cases, like the Handstar's SkyMapper will appear to be blank. This happens when the object is so faint that it doesn't appear in this telescope image. In these cases, make your classification based on the 2 mass and unwise images. Okay. Well, we do see something there, huh? That's not quite round. Well, so that's not quite round, but it's similar all around. So okay, that makes me feel better about it. Similar shape, so it's something that affected all of these, not a physical shape of this object. So let's see, what are our options here? The object moves off the crosshairs in only the 2 mass images. The object moves off the crosshairs in 2 or more images. The object is not round in the pan stars, sky mapper, or 2 mass. The object is extended beyond the outer circle in the NY, 2 or more. Not 2 or more. It's not extended beyond the outer circle. Pan stars? Where's the pan stars? Hold on, am I blind? Pan stars is from what? What camera is the pan stars? There's not a pan stars in this one, is there? I don't see pan stars, so okay, but that's fine. I'd say it's round. It's beyond the inner circle, but that's okay. As long as... the object moves off the crosshairs in 2 or more images. No, it doesn't. The object moves off the crosshairs in only the 2 mass images? Nope, it's there. These, though, extend beyond the inner circle. Is that a problem? I think that's good. I think that's good. It doesn't move off the crosshairs. You might say it's not round here and here, but the other objects have a similar shape, which they said... Where did they say it? No, that's where they were showing us not round. No, not here. Where did they say it? I'm clicking the same thing, aren't I? Oh, wait, what was this? Extended beyond the outer circle? No. Blank or noisy. Bad pixels. Not round, only in sky map. Here we go. Sometimes a few or all the images are going to show the objects oval or not round. This happens when the telescope has issues with its guiding in the moment of taking the images. resulting an easy clue to see if this is the case. Check the entire field in the sky mapper images. If this is the case, all objects in the image will show this effect, and not only the central one. There you go. That's what I was saying. So we have the similar shape for all of these. So the object moves off the crosshairs in the two mass images. No, it doesn't. The object moves off the crosshairs in two or more images. No, it doesn't. I mean, it's not really there in the sky mapper, though. Is that a problem? You're blank or pixelated like a video. This happens when the object is so faint that it doesn't appear in the telescope image. In these cases, make your classification based on the two mass and unwise images. Okay. I feel like it's round in the two mass images. It's not extended beyond the outer circle in the unwise images. Oh, so you're just not going to play the unwise again. Two or more objects. The object is extended. No. So I think that's good. I'm gonna say none of the above. I think it's a good candidate. Oh, that one's beautiful. It looks like. Oh, that one's a gimme, I think. The only tough part is in the two mass, kind of gets ovally, start to get a little ovally here, and we don't have anything to reference whether that's real or not. But going off the other two, it looks pretty round. I think that's a textbook good candidate. Next. Okay, nothing. That one's rough. That one's rough, I think. So when it says, so Sky Mapper is blank or noisy. This happens when the object is so faint that it doesn't appear in the telescope. So that's R. In these cases, make your classification based on the two mass and unwise images. Okay, so we're not looking at Sky Mapper anymore. Two mass and unwise. I'd say the crosshairs on there, right? The object moves off the crosshairs and only the two mass images. The object's barely on the crosshairs, but it's on there, I think. Object moves off the crosshairs in two or more images. The object is not round. Looks round to me. The object is extended beyond the outer circle. No. Two or more images. Hold on. What's the extended beyond the... Okay. No, I think we're still good there. Yeah. All right. I'm starting to get a little worried here because we've done none of the above for 3 of them. Okay. This one might be that the object moves off the crosshairs and only the 2 mass images. Well, it's kind of yeah, it's rough. I don't know. I think it's definitely off for the 2 mass images. Pan stars, I think, barely held on. Oh, I don't know. Hold on, pause. That's rough. That's close. Hold on. Sometimes an object can move off of the crosshairs due to its proper motion in the sky. But if this only happens at the 2 mass images, like the example below, remember to use the new option specifically for these cases. No, that's more clearly off the crosshair, right? So, I think this just barely passes. Looks around. Stays in the circles. We're gonna count it. What best describes the object you see? You may choose more than one option. Oh, I'm reading it like it's different. Guess I'm tired, huh? Okay, let's see. Round, looks good. Oh, that's funny. Pretzel rocks. I guess the musician behind it, his name is Joel K. But the Joel emote shows up for his name. Nice. On the crosshair for the 2 mass images. It looks around. To me. Beyond the outer circle and the unwise images? No, it's inside. 2 or more images. Show multiple objects? No. Man, I keep on forgetting I can emote. There you go. Yep. Okay, so we got blanks here in the sky mapper, so if I'm interpreting the directions right, we can just base it off of 2 mass. I don't know. All of these are looking good. Am I either really poisoning the data set or it's just good data? It's not outside the crosshairs. There's not multiple objects. It's round. To me. None of the above. Maybe you got some nice data. Yeah, well, I sure hope so, because I'm marking it as such. Okay, maybe one or two more, and then I think we'll call it. Time got away from me there. That dark energy one. Spent some time on that, I guess, reading the directions and just did nothing on it. But that one I just didn't want to take the risk on. This one is the total opposite. We're getting really good data, it looks like, if we're reading how to do this right. Oh, wait a second. Off the crosshairs. There we go. Off the crosshairs in the two mass images. Only in the two mass images. Jinxed it, yeah. That was kind of exciting, though. It was like, ooh, bad data. Gotcha. No, they are still solid. Sky Mapper, oh, off the crosshairs again. I'd say that's off the crosshairs. Yeah, no, that's off the crosshairs. Sky Mapper, I don't like Sky Mapper. It doesn't seem reliable as far as determining if it's round or not. Because I think it's not round, but then I see the other objects are kind of in a similar shape, and then... So, okay, same one as before. Object moves off the crosshairs and only the two mass images. Okay, this will be our last one. That one's it's that crosshair. It's walking the edge there. I don't know. So it's definitely round. Going off the pan stars and two mass, but the two mass, the crosshair's just kind of. That's tough. It is slightly outside the inner circle too, and I think that was another thing that we needed to make sure. Where did it say that? Then mostly within the outer circle. It may move a bit from the image to image, but does not move beyond the inner circle. Okay, so see, I'm gonna mark it off the crosshairs. And only two mass. Oh, I have not been looking at invert. I probably should. Wow, invert's actually really good. Totally forgot about that. Only in 2 mass. Okay. Okay, I lied. One more. Looks good. Only one object. Doesn't move out of the outer circle in the unwise. It's round. Not here, but that shape is there too, so. Not off the crosshairs. None of the above. End it with a good one. Okay. Too busy jamming. There you go. Yeah, no, I'm feeling the jazz over the lo-fi. I don't know what they were doing with that lo-fi playlist, but I like the jazz more, I think. Okay. Well, that was fun, I think. A little different, for sure. Not bad. I don't know. So I think that's probably it, though. I think everything else is kind of completed. So maybe this is something we just come back to every now and then, see if there's anything new. Otherwise, I think this was probably a one-off. Oh, if I get Moondiff, we'll be definitely coming back, because that sounds fun and interesting. But if I don't get access to Moondiff, then we'll just keep an eye on this, see if there's something new, and then come back to it when there's something new. So, but cool. That was cool. Tomorrow, I will, what do you call it? Probably, I was thinking about doing it tonight, but I think tomorrow I'll do the, start on the like R2-D2 type project. So start getting that going. Another STEM project, which might not be the most exciting thing, but you know, what I'm trying to do here, right, is I know I'm not the funniest guy in the world, right? So what makes me different? What makes me a different VTuber from all the other VTubers, right? It's that I know engineering. So I'm gonna try that out. I'm gonna try that niche. See if it takes us anywhere. If not, hey, I tried. And even if it doesn't, this is good stuff to put out to the public, just to, you know, anyone who's interested, you know, maybe someone else is trying to build a droid and they'll come across my videos and it'll be a help to them. So if that's the case, then it's worth it to me. So, anyway, have a good night and talk to you later. Good night.